Hi, in this lecture, we'll explore some aspects of constructors, why we need them, and some questions I often get asked by students learning object-oriented programming about constructors. So here I have an open VB project, and I have a default constructor for a triangle class. And our triangles will consist of a base, a height, and a name. Okay, right now I only have the one default constructor enabled. Have coded a couple other alternate instructors, overloaded parameterized constructors, but we're not dealing with those right now. Let's focus on this default constructor. And so in reading this, we see that when we create a new instance of the triangle class object, it should have a empty string and a base and height that are both set to 0. And let's explore that and see that that's really true. So over here, I've created a secondary form. I've set it as the default form for the project for the constructor lecture, and it's pretty simple. So it's just a form with a push button, and then I've set a breakpoint after the new triangle instance is instantiated. Okay, so all we're doing is calling new triangle. Okay, so that should fire off that default constructor, and let's see what that actually accomplishes. Okay, so our code is running, and we create that instance. We hit the debug point, and now I've got a watch window set with the default triangle instance we just created here. And if we expand this out, as expected, the double precision value of the height and the base are both set to 0. And indeed, the name is set to the empty string. I want you to pay special attention to the fact that the empty string is quote, quote, okay? That is different than a null. If it was a null, that would mean that the string was not set to anything. It would, for instance, if you were to ask the length of the string using the method to get the string length, right now it's going to say, well, it's an empty string, it's 0. If it was not initialized at all, you'd throw an error. Okay, so there is a distinction there, subtle but important. Okay, so let's go ahead and continue the run and end this. And here's the piece that's a little bit mind-blowing. So let's go back to our triangle class, and I'm going to highlight this default constructor, and I'm going to take this code out of play by commenting it out. Okay, so at this point, there is no explicit code as to how the compiler is to create a new constructor. However, we have already defined what the triangle object is supposed to look like because we have the class definition here. Okay, so the compiler is very obliging. It will actually create a default constructor for us implicitly if we do not explicitly provide it. And you would say, well, then why do we even bother? Watch and see. So with the default constructor commented out, it's going to have the compiler create, actually in this case it'll be the runtime engine will by default create a instance for us using a implicitly created constructor that we didn't even have to code, but that isn't necessarily going to give us what we want. Fire it off again, push the button, the instance is created, we hit the breakpoint. Now, if we look at this in Visual Basic, we still get what we wanted, which is the base is 0 and the height is 0. But look at the name string. It is not quote, quote. It is not the empty string. It is now a null. That is a distinction. The other thing that I want you to learn about programming in general in object-oriented programming languages, VB is a little bit odd in that it will assign numeric variable types a default value of 0 rather than leaving them at nothing. Most languages will leave it at nothing, and so you have an unassigned value. So it really is much better to use a default constructor rather than allowing the implicit constructor to do the work for you, because if these values are set to nothing, 0 we can work with, but if you try and do calculations on nothing, or an empty string we can work with. If you try and work with it, take the length of it, for example, and it's nothing, you're going to throw an error. So we want to be a little bit safer. So we want to explicitly create our constructors. Okay, so let's go ahead, continue, and end this and belabor the point just a little bit. So again, what may be clearer is, what if we made that constructor, that default constructor, do something a little bit more useful? Okay, so let's uncomment our default constructor, and instead of having it default to an empty string, let's have it say generic triangle is the name of a triangle that is completed or created that's not otherwise named. And let's have a standard size triangle that has a base of 5 and a height of 10. For our application, I don't know why a 5 by 10 triangle is more useful than just a generic triangle of 0, 0, no dimension, but let's assume that it is. So we can provide safe values, and you can think of objects that you would want to create where you would have specific values that would be more commonly used. So for example, if we were creating a person instance, persons might have gender, male or female. And so you might want to say, well, rather than leaving it empty, let's make one or the other, male or female, a default. So even if it starts with a value other than what we intend, it will at least be a validated value. The value will be a possible range, and that can be a better programming design than leaving it as null. Or you could even go with a third instance. Maybe you have male, female, or unknown. So you specify, all the generics, the first created as unknown, which tells you, okay, we have not yet identified the gender of the person for the person record, and so it tells you have more work to do to complete the record. Okay, so let's go ahead and run this with the default constructor made accessible again, and we run this and create the instance, hits the breakpoint, and now let's take a look at our watch window, and now we're getting a default of 5 and 10, and the default name is generic triangle, which we can then change. Okay. All right, and we'll continue the run, and we'll end it. All right, a couple other things about VB that let's demonstrate while we're exploring this, and that is, what if we try to have no default constructor, but overloaded constructors? So let's go back to our triangle, and first let's show you that these work. So here are a couple of overloaded constructors. So we can overload a constructor not just once, we can overload it multiple times, and all that really matters is that either the number of parameters we're passing to it or the data types of the parameters have to change. So I'm going to uncomment these, and then let's take a look at what do these do. Okay, so public sub new, that's our default. We have another public sub new. So we've named it exactly the same, and the way that the compiler can sort it out and know which one we're talking about, this version takes 2 parameters. It takes the length and the height, but it does not take a default for the name. So this one supplies an empty string as the name, and then what we ought to do is, instead of base is 0 and height is 0, we ought to set those to base equals base and height equals height. So that'll create it according to the parameters as they're passed in. And then we can overload it yet a third time, or a fourth time, or a fifth time, as many versions as you need in the overload as are useful for the way that you plan to use the object library that you are creating. Okay, so the class that you are creating. So let's see, this one now adds an additional parameter. And so the way the compiler knows the difference, this one has 1, 2, 3 parameters. This one has 1, 2 parameters. If you pass it 3 parameters, it's going to try and use this constructor. And this one will set name as the name. And then, oh, we ought to fix these 2 things as well so that they're not 0. And let's go ahead and run our code. Again, calling the default constructor, but make sure that it compiles. We're really more interested in the compile than the run, to make sure that it compiles with these overloaded constructors working properly. Okay, so we'll go ahead and start. It does the rebuild and compile. We run our default instance. We see it, and 5 and 10 in generic, so it used the default constructor as we intended. So we can go on with the run, and let's exit that. Okay, now here's what I wanted to show you about VB. Other languages may not work exactly the same way, but VB is finicky. If we come in here and we have the overloaded constructors, but we don't have an explicit default, let's see what happens. So let's go ahead and comment out just the default constructor. Now remember, this worked before when we didn't have these constructors present, or they were commented out. So let's see what happens. We go to run it this time. There were build errors. No, don't run the last version. Let's take a look at the build error, and it says, overload resolution failed because no accessible new, that's the new constructor, accepts this number of arguments. So now that I have overloaded, I can't just get away with letting the compiler provide an implicit um, default constructor. I have to actually have an explicit one listed here. So another reason why a default constructor can be required in VB. So let's go ahead and uncomment that, and let's just do the build. We won't necessarily run it. Rebuild solution, and this time it compiled just fine. All right, other remarks. We've talked about constructors, and the job of the constructor is to make sure that our new data object is created with the values, with the properties set the way that we would like. We provide an explicit default constructor to make sure that those are useful or safe values or optimal. And then the overloaded constructors make our job a little easier. If we already have the values, which is often the case for creating the object, we can create it from the get-go with them rather than having to write additional code to take a generically initiated instance and then update all of the property values as soon as we build it. Kind of saves us a step. The other thing we haven't talked about is if there's such a thing as a constructor that takes the job of creating the object, what about a destructor? Isn't there such a thing as a destructor? Absolutely there is. And in this case, and in almost all the cases in this class that we'll be working with, we use the implicit destructor, the one that the compiler creates for us automatically, because usually all it has to do is set the object instance to nothing, which is to say it tells the computer, you may now take back all of the memory that was set aside to store the value of this variable. A class is really just one big, very complex data type, just like a struct, even though it may have multiple data types in it. Same thing with a class, and generally that's all we need to do. Later on, when you take more advanced programming classes, you will learn that there are times when you may have done things that the implicit destructor cannot undo quite as easily. So for instance, let's say you create an object that creates objects. How do you keep track if you delete the parent object, that all of the objects that were spawned off of that, the children objects, all get cleaned up as well? A default destructor wouldn't be able to figure that out, in which case we would create the code to manage that if we wanted to make sure that when the parent object is destroyed when we're done with it, that any of the children are also cleaned up and destroyed. Otherwise, if you think about it, we would have orphaned out that memory that was put into use by the subsequent generation of objects. Never gets cleaned up, and it's kind of, we call that a memory leak. Eventually, if we run the program over and over and over again without restarting the computer, eventually we will impact the amount of available memory, or get it down to a point where the operating system can't run or the program can't run. All right, that's it for now. I hope that provides some further enlightenment about the use of constructors, implicit constructors, overloaded constructors, and a little bit of an inkling of the concept of destructors.